Hello. Good afternoon. Am I audible?
Yeah, ma'am, you are audible.
Okay. I think,
I just wanted to ask you something.
yes, please.
Is it the live session for week one or week two?
This is for week two.
Okay. Any other sessions are there for regarding this, or this is the only one?
No, actually, two more classes are happening, I think. You will have a link in the problem solving session. There you can
Okay.
access other meeting links also. One of the class is happening on
Okay.
Saturday,
So next Saturday or this today only?
every Saturday.
Every Saturday.
Yeah.
Okay. So that means for week two there will be one more problem solving session, right?
Yeah, every
Next
week
Saturday.
Saturday we have a problem solving session.
Okay.
Okay. I hope my screen is visible. Let's start. Um, is the presentation visible?
Yeah.
Okay. Okay, I welcome you all for the live session 2 for the course Basic Environmental Engineering and Pollution Abatement. With me, Mahalakshmi S. I am the research scholar from NIT-Trichy. So this is the general information that this live session for the course Basic Environmental Engineering, Pollution and Abatement will happen every Saturday from 3 p.m. to 5 p.m. I will be handling this session, and the Gmeet link is the same for every Saturday session. And you can also watch the live session video, which is uploaded in the YouTube channel named Mahalakshmi S. And these information will be shared through the Excel. You can also access the YouTube links through the Excel. So now let's begin the session with an overview of lecture 6, 7, 8, and 9. Okay. Okay. So this week lecture will have the basics of pollution, what is pollutant, and then different types of pollution. What are the causes and effect of these types of pollution over the environment and also over the human health and all. This is the brief overview of this week two session. So in the lecture, so in the lecture 6, we will start with what is pollution. So we all know that pollution is something bad to the environment. That environment is getting contaminated through different contaminants. Please join as early as possible. The session will be open from 2:50 itself, so that there is no disturbance in between. Okay. So now, pollution is introduction of any contaminants or any harmful substances into the natural environment that is going to cause a change over the normal ecological life. Yes. So pollution is going to cause the adverse effect over the environment. It can be any substances. It can be a chemical substance, or it can be energy like noise, heat, or light. Mainly, the pollution is classified into two types, which is because of the natural impact or through the man-made activities. So the natural, please mute yourself unless and until you have any questions. Okay. So initially, the natural type is like volcanic eruptions or the forest fires, which can emit a large amount of gaseous pollutants into the atmosphere. And coming to the man-made activities, it is like a domestic discharge of wastes, or from the commercial side, industrial perspective, whatever the wastes are disposed into the environment are causing the pollution. So usually this pollution is because of a pollutant. That pollutant can be in a gaseous form, which is resulting in the air pollution, or it can be in the liquid form, which is resulting in the water pollution, or it can be a solid, resulting in soil or land pollution. So what is the source of this pollution? It is basically classified into two types, which is the point source and the non-point sources. So point source will be having a well-defined origin. So it is like we know the origin of the pollutant, so it can be easily studied, and we will be knowing the methodology to avoid that kind of pollution. But in the case of the non-point sources, the diffused origin will be there. Like exact origin is not known. If you see the point source pollution means that effluents are discharged into the rivers, or the sewage water treated and then discharged into the rivers. All these will come under the point sources because their origin is known. But in the case of the non-point sources, if you see, it is mostly like the runoff. After running off in the of the landslides, or the running off of extra water from the agricultural side, having the high amount of pesticides, so all these things will be causing effect over the water. So those are all coming under the non-point sources. So it will be very difficult to treat them, and then we need to study the origin. So it is a very difficult process. Next is the impact of pollution. So the impact of pollution can be reduced. All these pollutant will be having impact over the environment. It can be reduced through these four methods. The first one is the dispersion. So the concept of reducing the impact of pollution is like uh, reducing the concentration of the pollutants. So in the case of dispersion, if you see that gaseous pollutants, when they are dispersed into the atmosphere at different levels, the concentration will be getting reduced for the particular area. So the concentration can be reduced through the dispersion. Or in the case of water pollutants, if you are diluting the polluted water, means because of the dilution, the pollutant concentration will get decreased. Deposition is like a sedimentation. Like you're filtering the solid wastes from the water. Like it by deposition method, it can reduce the concentration of the pollutants in the water. And then coming to the degradation here, it is a decomposition of the organic materials. It is by the natural activity. So it takes a large amount of time for the degradation of those organic wastes, and then reducing the concentration. So now coming to the water pollution, it is characterized by the presence of excess physical, chemical, or biological substances. Here, the eight substances you need to study. First is the physical substances. Physical is like the paper waste and also some plastic waste. All the materials which are all coming under the category like total solids. All the solid materials which is being disposed of in the water. So all those physical substances can cause the impact over the water. And coming to the chemicals, here the chemicals include the surfactants, detergent, which is having more amount of anions and cations. So chemically it is going to affect the water. So that what happens, the pH or turbidity of the water or are getting increased or decreased based upon the pollutant. And now the biological substances here are the BOD and COD. So BOD is the biochemical oxygen demand and COD is the chemical oxygen demand. It speaks about the oxygen demand in the fresh water, so that how much the water is polluted can be measured. So all the types of pollutant are going to cause the change in the quality of the water, and these are all capable of causing harm to the living organism. Obviously, water is the home for many living organisms like fishes and all. So their ecological life will be going to be affected. And this water pollution contribute is also contributed by the rain leachate. Whenever excess rain is happening in a place, wherever the contaminants present in the soil are all getting mixed with the rainwater, and they are going into the water bodies, and then the oil spill, and again the domestic and industrial wastewater. All these are the major contributing pollutants for the water pollution. Next is the air pollution. So here, the presence of abnormal amount of chemical constituent in the air. Normally, the air is fresh. Okay, whenever gaseous pollutants are emitted into the atmosphere, say for example, the particulate matter, which can be coming from the combustion processes. So all these SOx, NOx gases will be emitted into the atmosphere. And then the soil pollution. So the soil pollution is also called as the land pollution. It is highly correlated with the water pollution. So whatever present in the soil, when it is getting mixed with the water, is again going off into the water body. So it is very much linked to the water pollution. And mainly the soil pollution, all the solid waste is dumped into the soil or mostly coming from the industries and households. In the case of industries, the industries are classified into three types, which is red, orange, and green. So red is very much toxic to the environment, and orange is moderately affecting the environment, and green is like eco-friendly wastes from the industries. Next, coming to the lecture 7. So here we will be discussing about the impact of the pollutions. So if you see the water pollution, the major impact is the physical, chemical, biochemical, and microbiological. As we discussed earlier, all the suspended solids which were present in the water will increase the TDS, total dissolved solids. So the salinity of the water, and then the turbidity of the water, and also the taste of the water, color, everything is going to be affected by the physical contaminants. And coming to the chemical properties, as we discussed, so all the pH and then electrical conductivity, all these things will be getting increased. When we are seeing the microbiological contents, if you are seeing that seepage water, when it is untreated and it is being disposed of into the water bodies, what happens is the all the human waste will also get mixed with the fresh water. So to measure the amount of pollutant biologically present in that wastewater, what we will do is we will take the Escherichia coli, E. coli, which is here mentioned as the fecal coliform, as an indicator to measure the amount to which the water is polluted. And the major impact because of this water pollution is DO depletion. DO is the dissolved oxygen, that is very much important for the aquatic organism. And next is the arsenic contamination. So the heavy metal contamination will cause major impact, especially when in the case of arsenic, it will cause the skin damage, nerve damage, and then it is also a carcinogenic substance. So it can also cause cancer. And then the fluoride contamination, excess amount of fluoride into the water bodies will cause a disease called fluorosis. So this fluorosis can be a skin fluorosis. So it will affect the body posture, or it can be a dental fluorosis, which can affect the tooth. And then the high nitrate levels. So these nitrates, how they are coming into the water bodies is mainly because of the agriculture. So nowadays, a higher amount of chemical fertilizers are being added irrigation land. So what happens is the excess amount of fertilizer will be leached into the ground. So higher amount of nitrate are getting mixed into the running waters. So what happens here is the higher amount of nitrate level when it enters into the water bodies, it will cause a condition called methemoglobin. Like it will be attaching to our hemoglobin complex, and it will cause a suffocation in breathing, and it is also called as the blue baby syndrome. And mm, and this is a oxygen's sac curve. It is also called as the spoon curve since it is like looking like a spoon. It is based on the one-dimensional data. It is developed by Streeter Phelps. And here, if you see, the water body is divided into different zones. So the first zone is the clean zone. So clean zone means the amount of dissolved oxygen in the water is very good. So the water is saturated with the D. And then there comes the decomposition zone. The level of the dissolved oxygen is now getting decreased, because of which what happens is the amount of living organisms will get reduced. And then in the septic zone, it is completely depleted. It is very much less than the critical limit. So what happens that no living organism can live there in this septic zone except some microorganism. And then there comes the recovery zone. Like after some amount of time, the river will undergo a self-purification process, and naturally it will fix itself by absorbing the dissolved oxygen from the atmosphere. And then here in the recovery zone, what happens is the aquatic life will start reappearing slowly. And then there comes the clean zone. Like it will reach the optimum amount of dissolved oxygen required, so that all kind of organism can again appear in the water bodies. So this is the oxygen sac curve, which is very important to calculate the amount of dissolved oxygen. And now coming to the air pollution impact, mainly the particulate matters are the major concern in the air pollution. Based upon its size, it is having different effect over the human health. If you see that our human air is of length of 50 to 70 micrometer, and if you see a particulate matter of 10, it is less than 10 micrometer. Mainly the moles and some dust particles will be of this size, and when these PM10 getting entered into the respiratory system, it will enter to the trachea. And then if you are seeing the PM, particulate matter of size 2.5, so whatever the particles less than 2.5 are mainly coming from the combustion particles, and then the organic compounds and metals. These things will get entered into our alveolus. And the PM 0.1, which is very minute, this is coming from the gaseous contaminants. These will be having the ability to penetrate into the other organs through our cardiovascular system and nervous system. So like this, because of these particular matter emissions, the humans are affected by the breathing problem, like asthma, and then because of the haze it is causing in the environmental atmosphere, it will cause visibility impairment, and then it can also causes many damages to the monuments, which is coming under the category aesthetic damage. And then the plant damage. What happens here is higher amount of these gaseous pollutants in the atmosphere will affect the photosynthetic ability of the plants, so that it is causing the damage to the plants. So now whenever the hydrocarbons, so here hydrocarbon is our fuel. So fuel is rich in hydrogen and carbon. So whenever this hydrocarbon is reacting with the NOx and sunlight, what happens is it is causing the photochemical smoke. That photochemical smoke contains the oxidants like ozone and the formaldehyde and the peroxyacetyl nitrate. These are the major oxidants present in it. And then coming to the soil pollution impact, the major root causes include the agriculture. Soil is highly polluted because of the agriculture, because of excessive use of fertilizers. And then the poor management and disposal of solid wastes. And then there comes the excessive industrial activity. The major impact which includes like entry of arsenic. Arsenic is a heavy metal. We already know what kind of damage this arsenic can cause to the human beings. So when this arsenic is entering into the rice means then it is a very big problem. And then at the entry of heavy metals, pesticides in the vegetables, when the human beings are consuming these pesticides and heavy metal rich vegetables, again it is going to cause some health risk to the human beings. Then noise pollution impact includes the annoyance to the people. So what happens whenever there is a noise which is above the threshold limit, then we human beings cannot tolerate it. Sometimes the regular exposure can also cause loss of hearing, and it can cause the physiological effects, sleeplessness, and then it reduces the performance of the human beings in their day-to-day life. And it can also cause some damage to the material whenever like the ultrasonic waves, which is constantly exposed to some buildings, then it can also cause some damages to the material. Then some more effects of the pollution is the ozone layer depletion. We know that very well, and then the global warming. These are all the impacts are happening because of the different types of pollution. And this is that carboxyhemoglobin formation because of the carbon monoxide. When the carbon monoxide is inhaled, it is going to bind with the hemoglobin in the blood, and it is going to form a carboxyhemoglobin, and it reduces the oxygen carrying capacity. So it causes the breathing illness. So here the percentage of carboxyhemoglobin can be derived using this formula. This will be helpful to solve the problem. So please note it down. So percentage COHP is equal to beta into 1 minus e power minus gamma t into CO. So percentage COHP is the percentage of carboxyhemoglobin, and then CO is the carbon monoxide concentration in ppm, and gamma is 0.402 per hour. So this is constant, and beta is 0.15 percentage per ppm of CO, and T is the exposure time in hours. So here you will be asked to find the percentage of COHP where the CO concentration time is given, or the CO concentration and percentage is given, and the time will be asked in your exam. So in these three parameters, any one of the parameters will be unknown. Like this, we will be having some problems. So coming to the lecture 8, it is dealing with the pollutant impacts only. And first is air pollution dispersion. As we discussed, like one of the method to reduce the impact of pollution is the dispersion. And this dispersion is mainly going to reduce the gaseous pollutant, distribution of air pollution into the atmosphere due to the diffusion and advection. What is advection means? It is like a flow of some particle through the fluid. Here it is through the air. So that what happens? The pollutant concentration will be getting decreased. And in the case of advection, the strength depends on the strength of the wind and also the direction of the wind. Then only the reduction in the pollution impact is decided. Next is the atmospheric stability. So atmospheric stability is the measure of air's tendency to discourage or deter the vertical air motion. How it is going to affect the normal air tendency. It is of three types. The first one is the unstable atmosphere. So in the case of unstable atmosphere, there will be enhanced vertical movement of air. And in the case of stable atmosphere, it will suppress or it will be resisting the vertical motion. And then in the case of neutral atmosphere, it will neither suppress nor enhance the vertical motion. And then environmental lapse rate. It is the rate at which the air temperature is going to change with respect to height. So in the case of this air pollution, we will be having the problems which can be solved using these formulas. You can note it down. The first one is the point source Gaussian flow model. This equation can be used to solve the uh, problem, and in this one C is the concentration at the ground level. So if you see, if you're burning a coal substance and the coal is containing some pollutants like sulfur, and if you want to find the amount of sulfur dioxide concentration or amount of nitrogen dioxide concentration at a particular level means we can use this equation. Next is the Holland's formula. It will be giving the pollution at what height after the plume rise. If you are seeing this, H is equal to small h plus or delta h. Here H is the effective start height. Like after the plume rise, how much the height is differing from the physical stack, and at the point, what could be the amount of pollution. So you can note down these formulas, which is helpful in solving the problem. We will discuss the problems based on this later. And now coming to the lecture 9. So lecture 9 is about the impacts over the groundwater mainly. So first thing is the aquifer. So aquifer here is a body of a rock or sediment that is going to hold the groundwater. So when the subsurface get contaminated by the populations to the soil, we will be calculating how much contaminant is present there, how it is going to be sorted. Now, we have seen in the last week session, like Darcy's law will be used to predict the flow of the liquid into the porous soil. In the case of the groundwater contamination, we can use the Darcy's law to calculate pollution level. So now the groundwater Darcy velocity is equal to K hydraulic conductivity into the head difference, H2 minus H1, and L is the distance between the heads. Uh, Next is the chemical retardation. So the chemical retardation is a contaminant tends to react with the porous media. So whenever the contaminants is going to react, it is going to cause some retardation in the movement of the water. And then the retardation factor. This is very simple. So retardation factor is the ratio of the total contaminant in the aquifer to the contaminant in the groundwater. And it can also be given by the V of water and V of contaminant, which is the average velocity of water and the contaminant. So here retardation factor is dimensionless since it is a ratio of both velocity. And if you see this example, like retardation factor 1 means all are dissolved in the groundwater. Retardation factor 5 means it is 1/5, right? So in the 100%, 20% is dissolved in the groundwater and 80% is absorbed to the aquifer soils. So this is how the retardation factor is calculated. Next, dissolved oxygen concentration. So the major impact of the water pollution is the level of the dissolved oxygen, right? So how much dissolved oxygen is deficit in that water body? This rate of DO deficit can be calculated by subtracting the rate of deoxygenation. At what rate the oxygen is getting depleted in the water body, and minus the rate of aeration. At what rate the oxygen is again being aerated into the water body. So next, we will solve some sample questions for assignment 2. Since the week 1 assignment deadline is not yet over, I cannot discuss the assignment 1 answers. Next week, we will discuss assignment 1 and 2 together. As of now, do you have any doubt in the lecture overview? Do you have any doubt? Okay, we will solve the some sample questions of assignment 2. Am I audible? There is no issue, right? Can someone confirm through message? Okay, I hope I'm audible. So the first question is geogenic arsenic in groundwater is an example of what? Whether it is a natural pollution or pollutant or a man-made pollution, artificial pollution, none of the above. The question is indicating that arsenic in groundwater, but it is mentioned as geogenic. So geogenic means it is from earth, right? So it is a natural pollution or pollutant. Next is the pollutants which remain intact when released into the environment because they do not break down by the natural process or termed as dash. Anyone know the answer? So this is the
Persistent pollutants.
yeah. So this is the pollutant which is going to remain intact. So intact means it is cannot be broken down. So the answer is the persistent pollutant. Next is the anions. Anions such as fluoride, chloride in wastewater are categorized as. We know that there is a physical pollutant, chemical pollutant, biochemical, and microbiological pollutant. Um, what type it is? It's simple only, no? So they are asking whenever the fluoride and chloride are getting released into the water, it is going to contaminate. So these fluoride and chlorides are the chemicals. They are coming from the chemicals, so this is chemical pollutants. Next is the wastewater from pulp and paper industry contains mainly. So it can contain many things. What is mainly present in the pulp and paper industry is soaps and lignin. Next is which of the following sector has highest contribution to PM 2.5 emission to air? Any guess? Whether it is power, industry, transport, biofuel?
The transport.
Yes, mainly because of the vehicle transport. So we know that Delhi is one of the mostly polluted city, right, in our India. So mainly the PM 2.5 is released into the air through the transportation. So now this is the skeletal disease. Uh, the skeletal disease in the following picture is caused by the long-term consumption of dash contaminated water. Anyone knows the name of the disease? Or with the picture, can you say because of
Chemical fluorosis.
yes, yes, this is
Chemical and
skeletal.
anti-fluorosis.
Yeah, this is a
And this is
skeletal.
a fluoride.
Hmm.
Fluoride.
Yeah, answer is fluoride. Correct. So the condition is called the skeletal fluorosis. It will cause damage to the bones so that the person cannot stand or walk properly. So, and it is because of the higher amount of consumption of the fluoride contaminated water. Another condition is called dental fluorosis. It will be affecting the teeth of the people. Next, the ratio of total contaminants in a unit volume of aquifer to the contaminant dissolved in groundwater is known as, just now we have discussed. What is this? Retardation factor, porosity, contaminant concentration, water quality index. So the answer is retardation factor. Retardation factor is the ratio of the total contaminant in the aquifer to the contaminant dissolved in the groundwater. Okay. Next, match this following, which is physical, chemical, and microbiological characteristics. So which option is correct? What is TDS? TDS is the total dissolved solid, right?
This is the first option, Q3, Q2, R1.
Okay, we'll see. It is option 2. Hardness is the physical characteristics. And then TDS and conductivity. Conductivity is a chemical characteristic. And then the prions is some neurological problem which could be caused by the microorganism. So the answer is microbiological characteristic. Next up. Now we will solve some tutorial problems, and in the same order we will also discuss some similar problems like given in your tutorial. Okay. So now have you solved this week's tutorial problem? Tutorial 2. So this problem solving session is for you. So I want you to solve down with me. If you have any doubts when you work out only, you will have some doubts. I will explain this problem. This is a tutorial problem. There is another similar problem in some sample question that you solve by yourself. So now find out the air to fuel ratio required for complete combustion of a liquid fuel, which is having the average formula of C7H30 in a internal combustion engine. So the first thing you have to do is the stoichiometric equation. You have to balance the equation. So here your fuel is C7H30. This is a hydrocarbon, right? So you have a fuel which is given as C7H30, and you have the burning your fuel for the complete combustion. What you will be giving is air, right? So the air is composed of oxygen and nitrogen. How much oxygen is there in the air? How much? 21 is what? O2, and 78 is nitrogen.
Nitrogen.
Yeah, this is the volume percentage. Okay. So first you need to balance this. For 7 carbons, you will be getting the output of carbon dioxide as 7. So you need to balance this. So you will be having some 14 oxygen here. And then you will be having the water. In here you have H13, right? And all the H will be converted into water. If you are having H13, how many H2O will be there? 6.5 H2O will be there. And then for 6.5 H2O, 6.5 oxygen is there. And here the for 7 CO2, 14 is oxygen is there, O is there. So 14 plus 6.5 is 20.5. For O2, you are balancing it as 10.25, right? So now we have balanced the carbon dioxide, then the water and the oxygen. Now we need to find how much moles of nitrogen is there. So here you know the composition of oxygen and nitrogen in the air. So you are multiplying it with 78 by 21 to arrive at the nitrogen percentage. Okay, and then you need to calculate the molecular weight of each component. And then the formula of this is what is the mass of the air initially you are supplying, and then you will be dividing with only the mass of the fuel. So here the mass of the air, first here 1066 is the mass of nitrogen, then 328 is the mass of oxygen. So you're adding this and you are dividing the with the mass of the fuel. So you will arrive at the air to fuel ratio, which is 14.37, right? So and now I want you to calculate the same air to fuel ratio for different formula. This one. Calculate it. We have discussed it for C7H13, right? I want you to calculate for C6H13. Please work out and tell me the answer. Then we will see the solution. Molecular formula is C6H13. In a similar way, we have to add with O2. The reactant will be a hydrocarbon, oxygen, and nitrogen. And then the product will be carbon dioxide, H2O, and nitrogen. Please solve it. Have you balanced the equation? Has anyone solved the equation? Can you tell the stoichiometric equation? Did you understand the previous problem? It's easy only. What is the answer? Okay, we'll see the solution. The answer is 14.8. So how it is solved means, so for C6H13, we require 9.25 moles of oxygen, and we require 78 by 21 into 9.25 nitrogen. So that it produces 6 moles of carbon dioxide and 6.5 moles of H2O and 34.35 nitrogen. I hope you also get the same stoichiometric equation, and we are finding the molecular weight of the fuel as well as the oxygen and nitrogen. So you have to calculate the air to fuel ratio using the formula mass of the air by mass of the fuel. So in the case of mass of air, so the mass of the air is calculated by adding these 296 and 962. So how 296 is calculated means 32 is the molecular weight of oxygen into the moles 9.25, and 962 is calculated by multiplying 34.35 moles into molecular weight 28 of nitrogen, dividing it with the mass of the fuel, which is C6H13. So 6 into 12, which is the weight of carbon, and 13 into 1 is the weight of hydrogen. So the answer is 14.8. This is a simple problem. We have one in tutorial and this one is the sample question. Next, we will solve this problem. We have a sample question in the same time. Carbon dioxide is emitting from a 80-meter high industrial chimney of diameter zero point 0.5 meter to the atmosphere of 1 bar pressure on a clear summer day. Wind speed at 10-meter height from the ground is 4 meter per second. Calculate the effective stack height. Assume P category stability, so the P value is given as 0.15, and then the stack gas velocity is 8 meter per second, and the temperature of the stack gas and the ambient air at 80-meter height are 50 degrees Celsius and 25 degrees Celsius respectively. So what you need to calculate is the average stack height. That is the effective stack height. So whenever they are asking the effective stack height, we know that effective stack height is capital H is equal to small h plus delta h, right? So the small h here is uh, 80, and you have to 80 is the small h, and you need to calculate the delta h. So the delta h is always obtained from the Poland's formula, right? So delta h is equal to Vs by Q d into 1.5 plus 2.68 into 10 power minus 2 into pressure into TSR, which is the stack gas temperature, and T, which is the ambient temperature, divided by TA into D. D is the diameter, which is 0.25 already given. P is the pressure. It is given as 1 bar. We can convert it into kPa. So 1 bar is equal to 100 kilopascal. And then again here the diameter is 0.25. Then B is stacked flue gas velocity. It is also given. Then U you need to calculate. So in this one, we need to calculate the U2. We know that uh, carbon dioxide emitted from the height of 80 meters, right? And the wind speed is happening at the 10-meter height from the ground. So here your Z2 and Z1 are the different height at the respective meter. Uh, at that Z1 you will be having the velocity of U1, and Z2 you will be having the velocity of U2. You know the velocity at one particular height, which is 4. That's already given. At 10 meter, the wind speed is 4 meter per second. So you are calculating what is the speed at 80 meter. And here the probability is taken as 0.15. So the value of O2 is 5.464 meter per second. It is calculated. Now you have all the unknown values to calculate the delta H. So you know delta H is Vs. Vs is already given. Vs is the stack gas velocity, which is 8 meter per second into D. D is the diameter, 0.25 meter, and U2 is 5.464. And then 1.5 plus 2.68 into 10 power minus 2. The pressure is 10 power 2, which is 100 into Ts and Ta are given, which is 50 degrees Celsius and 25 degrees Celsius. So you are converting this degree Celsius into Kelvin. So which is 323 minus 298 by 323 into 0.25, which is again the diameter. If you solve this, you will get the delta H as 0.568. What is asked in the question is they ask you to find the effective stack height. You know the formula, right? So the effective stack height, already the height is 80. From there, it has raised to 0.568 meter. So the effective height is 80 plus 0.568, which is 80.568 meter. Okay. You have any doubt in this problem? Any doubt in the previous question? So we have a one more similar question. So I want you to solve this question. So you know the answer is 75.566 meter. It is already given. You need to use this formula. I will read the question once again. The carbon dioxide is emitting from 75 meter. So this is one difference. Previously it is 80 meter. Now it is 75 meter. High industrial chimney of diameter 0.25. It is same to the atmosphere of 1 bar pressure. That is also same on a clear summer day. Wind speed at 10 meter height from the ground is 3.8. So 3.8. That is different. So, at 10 meter, wind speed is 3.8 meter per second. And here also the same question is asked. You need to calculate the effective stack height. Next, assume B. So B category stability. So P value is same 0.15 and the stack gas velocity Bs is 7.5 meter is given and the temperature of the stack gas and ambient gas at 80 meter is 50 degrees Celsius and 25 degrees Celsius. Now you need to calculate the delta H and you need to find the effective stack height. Please solve this problem. Just same like the similar previous question. You just need to substitute these respective values in the formula. If you have any doubt, you can ask. Okay, hope you are solving it. First, this is the Holland's equation. We need to find the PS, which is the stack velocity, which is given as 7.5 meter per second. Just substitute it. And then the D. D is the stack diameter, and it is 0.25 meter. So it is also substituted. Next, U is the wind speed. So now the wind speed at what height? At our new stack. It is determined using the U2. U2 is equal to U1 into Z2 by Z1 whole power P. So the probability is given as 0.5, and then at the 10-meter distance, the wind velocity is 3.8 meter per second. It is already given. So we need to find the wind velocity at 75 meter. So we use this formula. So U2 is equal to 3.8 into 75 divided by 10 whole power 0.15. So which gives the U2 as 5.141 meter per second. And now U is also substituted. U is the wind speed here at the 75 meter. Next is 1.5 plus 2.68 into 10 power minus 2. Here the pressure is same. So the pressure is 1 bar. So it is 100. And TS and TA. TS, stat gas temperature is 50 degrees Celsius. So 50 plus 273 is 353. And ambient temperature is 25 degrees Celsius. So 273 plus 25 is 298 Kelvin divided by Ts, again 323 Kelvin into the diameter of the stack, which is 0.25. So if we solve this one, we will get 0.566 meter. So they have asked the effective stack height. The formula is effective stack height is equal to, so this is the capital H. So the capital H is equal to small h plus the difference in the height, which is the delta H. 75 plus 0.566 is equal to 75.566 meter, which is the effective stack height for this problem. Do you have any doubt in this problem? Any doubts? Okay, we'll go to the next problem. So this problem is related to the water pollution. This is a tutorial problem. The question is a phosphorus limited lake with surface area equal to 90 into 10 power 6 meter square. So 90 into 10 power 6 meter square is the surface area of the lake, which is fed by 18 meter cube per second stream. So the stream flow rate is 18 meter cube per second. That has the phosphorus concentration of 0.010 mg per liter. And in addition, effluent from point source add zero point 0.9 gram per second of phosphorus. So the concentration of the phosphorus being added from the point source of pollution is given. The phosphorus settling rate is given as 10 meter per year. So the question is to calculate the average total phosphorus concentration at the end. And then the what rate of phosphorus removal at the wastewater treatment plant would be required to keep the concentration of phosphorus in the lake at an acceptable level of 0.010. So here the acceptable level is fixed as 0.010 mg per liter. So at what rate the phosphorus should be removed in the treatment plant they are asking. So one by one we will go. First thing we need to find is the input. So something is going in, and in the wastewater treatment plant it is getting treated, something is getting accumulated, and to the incoming stream from the point source the effluent is also constantly being added. Okay, so the inlet stream is the incoming stream plus the point source addition, and then which is equal to QC out, what is being left out, and then what is being accumulated in the wastewater treatment plant. So now we are going to find the QC in, which is Q is the flow rate and C in is the input concentration. So the inlet flow rate is given as 18 meter cube per second. And what is the concentration in the inlet stream means the inlet stream is having the concentration of 0.01. So we are multiplying Q into C to find it. The answer is 0.18 gram per second, right? Now, zero point 0.9 gram per second is constantly being added to this incoming stream. So that is also going to the wastewater treatment plant. So we need to add this. And now the input rate is 1.08 gram per second. So what is the estimated settling rate? It is already given, right? So the settling rate is 10 meter per year. It is given in year. So we are converting it to seconds. So we are multiplying 365 into 24 into 3600. 365 days, 24 hours, and it is 60 into 60. So 60 minutes, 60 seconds. So the VS is 3.17 to 10 power minus 7 in the unit of meter per second. So this is the mass balance equation which is used to solve this problem, which is QC in. This is the inlet stream, flow rate of the water and the concentration of phosphorus in the inlet stream plus S is the point source addition which is being constantly added. Okay, and then uh, at steady state, this equation is arrived. Then area into settling rate Vs and C out is the outlet concentration, and again Q is the same flow rate and C out is the outlet concentration. So here we need to find the C out initially. That is what asked. So we are rearranging this equation. We can take the C out and C out, which is common in this, and it will become AVS plus Q into CO. So we need only CO. So we are dividing QC in plus S by Q plus VS E. This is how this equation is derived. Okay. Now we know that the inlet concentration is 1.08 after adding the point source. Then Q is the 18 meter cube per second and VS is calculated, which is 3.17 into 10 power minus 7. And then area is also given, which is given here. The surface area of the lake is 90 into 10 power 6. Okay. So after solving this one, we will get 0.023 mg per liter. This is the out concentration of the phosphorus in the river. This outlet concentration is 0.023. It is exceeding the value of 0.010. They have mentioned like the acceptable level of the phosphorus in the stream is only 0.01 mg per liter. But the output stream is having the concentration of 0.023. That's beyond the limit. So to control the eutrophication, what we have to do is what should be the loading from the point source they are at. So now we need to calculate the S. Okay. So if we are calculating the S, again we need to rearrange this equation into AVS plus Q into C out minus this will come this side. So it is written as minus QC in. So here the concentration is 0.01 and Q is 18, BS is 3.17 into 10 power minus 7 and area is 90 into 10 power 6 minus QC which is 18 into 0.01. So if we multiply we will get 0.29 gram per second. At this rate only phosphorus should be loaded, they are telling. So now what should be the how much extra rate should be there? To find that, we have to subtract this. 0.9 minus 0.29 divided by 0.9. Then you will get this percentage is 67.8 percentage of phosphorus removal is needed. So that what happens means if you are removing the phosphorus at the rate of 67.8 percentage in the wastewater treatment plant, then the phosphorus concentration in the outlet can be maintained as 0.01, which is the acceptable level as mentioned in the question. So the first question is to find the average total phosphorus concentration, which is 0.023 mg per liter in the outlet. But to achieve the threshold limit 0.01, the S should be 0.29 gram per liter. So how much efficiently they need to improve the phosphorus removal is 67.8% higher. Do you have any doubt in this problem? Okay, we will move to the next question. This is also another problem from your tutorial. Uh, the question is a coal-fired power plant converts one-third of the coal's energy into electrical energy. The electrical output of this plant is 500 megawatts. So we need to note down the given data. In this plant, only one-third. This is also important. Only one-third. So whatever we are using, only one-third is of the coal's energy is converted into electrical energy, and 90% of the rest energy of coal is rejected to the river there then through using the cooling water drawn from a nearby river and recycling it back to the river. The river has a upstream flow, so the flow rate is 75 meter cube per second, and the temperature of the river water is 20 degrees Celsius. If the cooling water temperature increases by 5 degrees, so the rate of increase of the temperature of river water uh, is 5 degrees Celsius. What flow of cooling water stream is required? They are asking the flow rate. This is one question asked. And what should be the temperature of the river? Just after receiving the heated cooling water. So this is the question number 2. So the question is very clear. The context is in a power plant, the coal is fired, so that by burning the coal, they are deriving the electrical energy. For the capacity of the plant is 500 megawatts, right? So 500 MW. In this plant, only one-third of the coal used is converted into the electrical energy, and the remaining two-third is not converted there till. So in the two-third of the coal energy, 90% is being rejected into the river water through the cooling water mechanism. So whenever this energy is released into the cooling water, the river temperature is getting increased at a rate of 5 degrees Celsius. So the question asked is, what is the flow rate of the water stream required? And also, after receiving the heated cooling water, what will be the final temperature of the river water they are asking? So first we know the input power is 3 into 500, which is 1500 megawatts, right? So 500 is the output, and this output is only the one-third of the coal energy. So output is one-third. Then what could be the input? 500 into 3. Thrice as 500 is given, only 500 is converted. So 1500 is the input power. Next is energy lost through the water. So we know 90% is lost. We know that in this 1500, what is the two-third? So two-third is 1000. That is also calculated as 1500 minus 500, which is 1000 megawatts. Okay. So the input power is 1500. In the 2000, two-third, which is 1000 megawatt, is not converted. Only 500 is converted as the electrical energy. So in this 1000 unconverted energy, 90% is lost through the water. So we are multiplying 1000 into 0.9, which is 900 megawatt. This is lost through the water. Okay. Now, this is the question being asked. First question is, what flow of a cooling water stream is required? So, the flow rate of cooling water stream is achieved through this formula. Q is equal to P divided by C into delta T. Okay. So, here P is the power. Next, C is the specific heat capacity, which is already mentioned here. Okay. It is here, mentioned already. Then delta T is the change in the temperature, which is only 5 degrees Celsius. That is already given in the question, right? So now substituting all the calculated values, 900 into 10 power 6. This is the power lost into the water, divided by 4184 is the specific heat capacity of the water at 20 degrees Celsius. Why 20 degrees Celsius means the temperature of the river water is 20 degrees Celsius. Next, into 5. 5 is the delta T. It is the rate at which the temperature is increasing. Then we will get the value 43011 kilogram per second. So we are converting the kilogram to meter cube. So you know 1 meter cube 1 meter cube is equal to 10 power 3 liters, right? So to convert here you are assuming like 1 liter is equal to 1 kg. So you are converting the kg into meter cube. So you are dividing it by 1000. So 43,011 is converted to 43.01 meter cube per second. Now the flow rate. The question 1 is solved. Flow rate of the cooling water stream should be 43.01 meter cube per second. Okay. Now you need to calculate the what would be the temperature of the river water after receiving the heated cooling water. So to find this one, initially you need to find the increase in river temperature. So you need to find the delta T. So the delta T here is P divided by m dot C. So here the power lost into the water is 900 into 10 power 6. And then mass flow rate of the water. You know the flow rate of the upstream flow is 75 meter cube per second. This is the flow rate that is substituted here. Then again C is the heat capacity of the water at 20 degrees Celsius, 4184. So now you have obtained the increase in the river temperature as 2.87 degrees Celsius, and then the river water temperature after entering the hot cooling water is 20 plus. This is the increase. So 20 plus 2.87 is 22.87 degrees Celsius. Is this clear? Okay. Any doubts so far? I am audible, right? Please confirm. Please confirm through the chat. Okay. 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 Thank you. Okay. This is another problem. I have given the equation earlier. Right. So the question is determine the carboxyhemoglobin concentration as a percentage saturation for CO concentration of 1200 ppm. The concentration of CO is given, which is 1200. after 0.5 hour of exposure. So the exposure time T is 0.5 hours, right? Further, determine the minimum time for 80% saturation. The first question asks us, we need to determine the percentage of COHP. So that is the first question. Next one is, for 80% saturation, what would be the time? We are asking the time again. This is the second question. Okay. So we know that this is the general formula. Percentage carboxyhemoglobin saturation is equal to beta into 1 minus e power minus gamma t into CO. So CO is the carbon monoxide concentration in ppm, and gamma is 0.402 per hour, beta is 0.15 percentage, and t is the time. So time given is 0.5 hours, right? So if you substitute here t as 0.5, and then what is CO? CO is 1200. It's very simple. And gamma is already given 0.402, right? Beta is 0.15. If you substitute this, you will obtain the percentage of COHP as 32.78. Okay, and we need to solve the part 2. This is not mentioned in your tutorial. Uh, can you please solve this? I will also give the solution. Here it is given as 8. It is given as 80. Concentration is same. They are asking the exposure time. As I said earlier, either CO can be asked, or percentage COHP can be asked, or T can be asked. Any one will be answered. Answer is 1.46 hour, but steps are not given. Simple conversion only, we will see. Okay. As mentioned, beta and gamma are constant. CO is given, which is 1200 ppm, and T is the unknown here in the second part. So we need to find the time T when percentage COHP is 80. So we are substituting the values in the equation. 80 is equal to 0.15 into 1 minus e power minus 0.402 t into 1200. So you are multiplying 0.5 with 1200 will give you 180, and 80 divided by 180 is 4 by 9, and 1 minus e power minus 0.402 is there. So now what happens is you are bringing this e power term to one side and all these term to the other side. So what happens is 1 minus 4 by 9 will be on the other hand. So when we solve this, we will get 5 by 9 is equal to e power minus 0.40t. To convert this term, we are taking the natural logarithm. So ln of 5 by 9 is equal to minus 0.402t. So now we will obtain the value of t is equal to 1.46 hours. Okay. The first question is to calculate the percentage of carboxyhemoglobin where the T and CO concentration is given. And the second part is asking you to find the time of exposure by giving the percentage CO and CO. They have given both of these. Okay, this is another simple problem. You can expect some questions from this. So now this is the another problem. Uh, a confined aquifer of 25-meter thick has two monitoring wells spaced 600 meters apart along the direction of groundwater flow. The difference in water level in the wells is 3 meters. The difference, this is the difference in the piezometric head. And then the hydraulic conductivity is 50 meter per day. Now estimate the rate of flow per meter of distance perpendicular to the flow. So it is asked to find the flow rate. We know that Darcy's law is Q is equal to Ka into pH by dl. So what is the given data? 25 meter thick. So thickness is given. First of all, what is the aquifer? We know that in the uh, so river body will be there here. Below that, some solid particles will be there. So the water trapped in this is called aquifer. So this thickness is given as 25 meter, right? Thickness is given as 25 meter and has two monitoring wells. So the distance between the wells are 600 meter, right? And then along the direction of groundwater flow, the difference in water level of the water in this well is 3 meter. So H2 minus H1 is given as 3 meter. So here you can directly calculate the dH divided by dl. That is H2 minus H1 is given as 3 meter and the distance between the two head is given as 600 meter. So this is a dimensionless value. 3 divided by 600 is 0.005. Now you can use the Darcy's law to find the flow rate. So you are considering that aquifer width is of 1 meter. Okay. So you can calculate the area by multiplying the width into the thickness. So now you know the K. What is K? K is the hydraulic conductivity that is already given, which is 50 meter per day. So 50 meter per day into area is 1 meter into 25 meter. You get 25 meters square into dH by dl, which is already calculated by dividing 3 by 600, which is 0.005. So if you multiply all these things, 50 into 1 into 0.005, you will get meter into here 1 meter and another meter. So meter is meter cube divided by day. This is the unit. So flow rate unit here is meter cube per day. Okay. So the answer is 6.25 meter cube per day. So now this is the next problem. This will be using the another equation. This equation. So we will use the Gaussian equation to determine this. Uh, so far, do you have any doubt? I could not hear you. Shatu? Okay, next one is a lengthy problem. Before solving that, I want to clarify whether any doubts are there. Okay, we will proceed. So now, the question given is 915 megawatt power plant with an efficiency of 40 percentage uses coal as the fuel source. So here the source is the coal, and the coal has 1% sulfur content. The amount of sulfur present in the coal is only 1%, and the calorific value of the coal is 30 megajoules per kg. The effective stack height is 520 meter. If the neutral conditions prevail, find out maximum ground level concentration. You need to note down this. Ground level concentration is only asked here. Ground level concentration of sulfur dioxide at 10 kilometer and 100 kilometer from the plant. So you need to assume U10 is velocity is 4 meter per second And sulfur, 32 is the weight, and the oxygen, it is 16. Atomic weight is 16. Next, exponent for velocity. So the p value is given here, 0.16. Now the sigma y and sigma z are given. Sigma y is 550 meter, sigma z is 140, and it is happening at x kilometer, means 10 kilometer. For 100 kilometer, sigma y and z is 4,450. So all the data are given. What is to be uh, what is to be find as maximum concentration at different kilometer, which is 10 and 100. So initially you need to calculate the amount of coal used, and in the amount of coal used, how much amount of sulfur is present in the coal. That is what we need to calculate. So in the question, again I will read it one more time. A 950 megawatt power plant with an efficiency of 40% uses the coal as the fuel source. The coal has 1% sulfur content and a calorific value of 30 megajoule per kg. The effective stack height is 520 meter. If the neutral conditions prevail, find out the maximum ground level concentration of sulfur dioxide at 10 and 100 kilometers from the plant. All the essential data are given. Firstly, 960 megawatt plant. So you need to do the unit conversion. So this is mega. So it is 10 power 6. Watt is converted to joule per second. It's the smallest. Okay. And then joule per second. And then mm, it is from seconds, it is converted to hour. We know that 1 hour is equal to 3600 seconds. So you need to multiply it. So this is into 3600. Then you will obtain 3294 into 10 power 3 megajoule per hour. Now the amount of coal required is, so this is a 915 megawatt power plant with an efficiency of only 40% is going to use the coal as the fuel source. So only 40% is converted into this much amount of energy. So how much coal is being used means, again you need to divide the obtained power with zero point 0.4 into 30. 30 is the calorific value of the coal. So you will obtain 274500 kilogram per hour. So 110 is equal to 1000 kg. So we will be obtaining 274.5 tons per hour. This much amount of coal is actually required. In this, only 40% is efficiently converted. So we are using the power to calculate the initial amount of coal required. So now the initial amount of coal required is calculated. So in 274.5 tons of coal, how much amount of sulfur dioxide is there? Okay, that is what we are going to calculate. In the question, it is given the coal is having 1% of sulfur content. So we are multiplying 274.5 into 1%, right? That is what is given in the question. So 1%, 1 by 100 means 0.01 into 64 divided by 32. Why? Because this is containing only 1% of sulfur. Sulfur is yes, right? But we are calculating the concentration of sulfur dioxide. So how much sulfur dioxide we are assuming is um, 64 is the molecular weight of sulfur dioxide, 32 is the atomic weight of the sulfur. So we are multiplying it with 64 and dividing it with 32. So we'll be obtaining 5.49 tons per hour, and we are converting again this to kg per second and finally to gram per second. So the final value is 1.5 into 10 power 3 gram per second. And converting is this here itself to make it simpler when solving the problem. So now this is the Gaussian equation, which is a Cx comma y is equal to E divided by pi sigma y sigma z into Q. E is the emission rate. It is also sometimes denoted as Q. This is just the rate, emission rate of the pollutant. And pi is the constant, 3.14. And sigma y and sigma z are given already, okay, which is the uh, plume dispersion standard deviation in the horizontal and vertical direction respectively. It is given in the question also. Next, U is the wind speed at the stack effective height h. That is also mentioned. Next, X is the distance down wind, and Y is the horizontal distance, and H is the effective stack. So this term is multiplied with the exponential of minus half the y by sigma y whole square exponential of minus 1 by 2 into h by sigma z the whole square. So our question is mentioning us to find out the maximum ground level concentration of sulfur dioxide. So for the case of ground level concentration, we can omit this term. Okay, we can only consider this term. So this equation is further simplified, and now we can solve this problem. Once again, we need all the data. So the effective stack height is 520 meter. We are going to find the SO2 concentration of 10 and 100 kilometer. So now at uh, at the distance of 10, the velocity is 4. It is mentioned in the question. So at the distance of 10, the velocity is 4 meter per second. It is already mentioned. So we need to find the velocity or a wind speed at the distance of 520. So we are using the same formula. U2 is equal to U1 into Z2 divided by Z1 whole power P. The probability is given in the question, which is 0.16. Now 520 divided by 10 is 52. 52 power 0.16 into 4 is 7.53 meter per second. Now we have obtained all the data essential to calculate the concentration at the different distance. So the first part of the question is to calculate the sulfur dioxide concentration at 10 kilometer, and second one is the 100 kilometers. Okay, and it is from the ground level one. So only we are cancelling the y term because y is 0 here. Now E, the exposure concentration. What is E? Sorry, emission rate of the pollutant. Here our pollutant is sulfur dioxide, right? At what rate is this getting emitted is for every 274.5 ton per hour of coal consumed, it is going to emit 1.5 into 10 power 3 gram of sulfur dioxide per second. So this is our rate. So we are going to substitute this SO2 emission rate here, 1.5 into 10 power 3. Next, pi value is constant, which is 3.14 into sigma y and z at 10 is already given. At 10 kilometer, it is 550 and 140. So 550 into 140 into u. So the average wind velocity is 7.53 meter per second. That will be constant for both the cases. So into 7.53. Next, exponential of minus half into h by s z. H is given as 520 meter and sigma z is 140. So if we solve this, we will obtain 0.832 microgram per meter cube. Okay. Then the second part is to solve the concentration of the SO2 at a distance of 100 kilometer. So again, E, the the emission rate of the pollutant is same 1.5 into 10 power 3 and pi is 3.14, and here the sigma y and sigma z is given as 4000 and 450. So 4000 into 450. Now into U is same 7.53 e power minus half. Effective stack height is 520 and the sigma y is 450. 450 the whole square. So you will obtain 18.08 microgram per meter. So this is very simple. First in the question you need to identify from what level they are asking. If it is ground level, then you can neglect the this y term in the exponential. Okay. Then with the help of the given data sigma y and sigma z at x kilometer, we can substitute and you can calculate. Initially, one thing is our pollutant is sulfur dioxide. Only the energy obtained from the power plant is given. So for obtaining this much energy, only 40% is consumed. So what is the 100% coal required is this much amount. From this amount of coal, 1% of sulfur content is present. It is mentioned. So we are calculating the sulfur dioxide by multiplying 2 by multiplying 2 and we are obtaining the rate of emission of sulfur dioxide as 1.5 into 10 power minus 3. Now all the data are obtained. Only thing you need to calculate is E is obtained, you need to calculate the U. U at the effective height is calculated using U2 by U1 is equal to Z2 by Z1 by whole power P. So by substituting all the given values sigma, y and z, we can calculate the concentration of the pollutant at any distance, like 100, 10, any x distance. Do you have any doubt in this one? Any doubts? Okay, I'm seeing people leaving, but I have one more question to be solved by yourself. It's related to phosphorus contamination. So for the same question, if the surface area of the lake is 80 into 10 power 6 meter square and flow rate is 28 meter cube per second. So this area unit is meters. Okay. And the phosphorus concentration is same. What you need to find is all the others are same. You need to find only the average or total phosphorus concentration. Okay. Please solve it. Then I will discuss the solution. Just the same question. You need to use the mass balance equation. And also see the mass balance equation here, which is QC in. You have the inlet and the outlet. The inlet or QC in and S, outlet or AVSC out plus QC out. Now you have to find the C out. So you have to rearrange the equation. By rearranging the equation, you will obtain the concentration in the outlet. For the new values, I have changed the surface area from 90 into 10 power 6 meter square to 80 into 10 power 6 meter square. And then the flow rate of the stream is changed from 18 meter cube per second to 28 meter cube per second. And the phosphorus concentration is same, which is 0.01. And the point source addition rate is also same, which is 0.9. And the phosphorus settling rate is also same, 10 meter per year. So we solve this problem for the changed values. Anyone got the answer? Okay, we will solve this one. We already know that this is the mass balance equation, right? So in this equation, what you need to determine is the C out. So you need to write. So here the C out is equal to, you need to rearrange that equation. It is already there. I'm just rearranging it. C out is equal to, if you take these C out common, AVS plus Q will be there. So QC in plus S divided by AVS plus Q. That is what you are having. So Q C in. I'm writing simply as I and then this is S divided by Q into uh, Q plus AVS. Right. So now the new Q is 28, right? So 28 into the inlet concentration is same, 0.01. Plus what is the point source addition? It is also same, 0.9. Divided by, again the flow rate is 28 plus What is the area? Area is changed. So the new area is 80 into 10 power 6 into Vs. Vs is same. It has not changed. Vs is 10 meter per year and it is transformed to meter per second. So when you are converting the meter per year to second, what is the new value here? This we can take from here. 3.17 into 10 power minus 7. So you have to multiply 3.17 into 10 power minus 7. If you solve this one, you get this here. Did anyone solve this problem? Okay. So we can try this one. The answer is 0.022 mg per liter. Obviously, as this changed the surface area and flow rate also, it is above the acceptable level. Okay, so here the acceptable level is given as 0.01, but the C out concentration is 0.022 milligram of phosphorus per liter of the water. So again, to this question also they are adding the part B as the previous question. Like what would be the rate of phosphorus removal at the wastewater treatment plant? If they are asking me, then you have to calculate the S like this. So S is equal to C into Q plus VSA minus QCE. Here C is say flow rate. Instead of 18, you need to put 28. Then settling rate is same. 3.17 into 10 power minus 7. And area is instead of 90, you need to put 800. Right. Then again here you will be substituting 28 instead of 8. Then you will get a S value of some in gram per second. So what you do to find the efficient rate of phosphorus removal to achieve the acceptable level is you need to subtract the obtained value from 0.9 gram per second. Then you will obtain the percentage of removal of phosphorus needed in extra to achieve the acceptable level of 0.01. So these are the some sample problems we have discussed. We have discussed the sample questions for the assignment 2. Some MCQs are discussed, and then in the case of problems, we have discussed this one, air to fuel ratio, how we can calculate. Air to fuel ratio can be calculated using the formula mass of air by divided by mass of fuel. To obtain this thing, first you need to calculate the stoichiometric equation of the particular fuel, and then you will calculate the mass of the O2 and N2 and the fuel to calculate the AFR. Next is we are calculating the effective stack height. These are all the problems related to the air pollution. So in the air pollution, we have seen two different problems. One is using the Holland's formula, which is going to calculate the delta capital, which is going to calculate capital H by calculating delta H from the Holland formula, and small h is already given in the question. And the next type of problem we have seen is water pollution based problem. In this one, the phosphorus contamination is happening. So in the wastewater treatment plant, they are removing the phosphorus. So by using the mass balance equation, we are calculating the total phosphorus concentration in the outlet. And finally, we are calculating the efficient rate of phosphorus removal to achieve the threshold limit. The main thing you have to keep in mind is the mass balance equation. Next one is, this is also a problem related to the air pollution. Uh, so when air pollution and also the water pollution in the power plant, you are burning the coal and some amount of energy is lost in the water. So when some amount of energy is lost in the water, the temperature of the water is getting increased. What should be the flow rate of the cooling water stream and what is the increase in the temperature? So when the temperature is exceeding beyond some limit, what happens is aquatic organisms cannot live in the water. So these are all some important problems related to water pollution. And again, this is one air pollution related problem which calculates the percentage COHP. By using this equation, the problem can be solved to find the unknown percentage carboxyhemoglobin or the exposure time or the carbon monoxide concentration. Next one we have seen is uh, determine the flow rate. This problem uses the Darcy's law to calculate the flow rate per meter of distance perpendicular to the flow. This is a confined aquifer water pollution related problem. Now, this is one big problem we have solved today. So in this one, at different levels, what would be the concentration of the pollutant? That is the question. We have to keep in mind whether it is the ground level or it is at a height. It is from a height. It is at some height from the ground level. If it is at a height from the ground level, then y should be considered. When they are asking us to measure the ground level concentration itself, then we can exclude the y from the equation. Then the equation becomes simple. This is also a air pollution related problem. Thank you for joining today's session. All the recorded videos will be uploaded to this YouTube channel. You can also rewatch the videos. And this entire presentation will be uploaded in the Google Drive. The link is already shared. You can access the content through the Google Drive and also through the YouTube. Thank you for joining today's session. See you on next Saturday.